welcome to this deep dive into the architecture of a real-time logistic coordination platform powered by Kafka, machine learning, and workflow orchestration engines. In this video, we will walk through how shipment data flows across the system from ingestion to decision making to the final customer notification and what each component does along the way. Let's get started. Here we have the external actors and we have shippers and clients. These are businesses or end users initiating a shipment. When a shipment is created, example via a mobile app or web form, a shipment.created event is emitted to Kafka. This event contains metadata like shipment ID, source, destination, time window, and priority. Next, we have carrier GPS devices or APIs. These stream location updates in real time. As truck moves, it emits shipment.location.updated events containing timestamp, latitude, longitude, and shipment ID. These updates are also sent to Kafka. Then we have the customer UI mobile app. This is actually a consumer of processed events. The UI will receive alerts, real-time status, and updated ETAs later in the flow. Next, we have event streaming layer, which has Kafka, and here Kafka acts as the central nervous system of this architecture. It has several topics: shipment.created, shipment.location.updated, delivery status, predicted.delay. These topics serve as buffers and brokers between producers, example, GPS devices, and consumers, example, tracking services. Here we can see the arrows from shippers and GPS feed into Kafka with blue arrows labeled shipment.created and shipment.location.updated. Kafka decouples producers and consumers, enabling parallel processing of real-time data streams. Next, we have core microservices. The first one we have here is shipment tracking service. This subscribes to shipment.start topics. It updates the operational DB with current location, shipment status, and timestamps. The data state here is that the shipment status is enriched and persisted for querying. Example, a shipment just left Chicago, expected arrival in Detroit at 3 p.m. Then we have prediction engine. This subscribes to the same location and delivery status topics. This applies machine learning models to predict delays based on traffic, weather, driver patterns, and historical trends. Emits new events like predicted.delay back into Kafka. The data state here is that the ML model evaluates risk and augments the event stream. Then we have business rule engine. This listens to predicted.delay and shipment.start topics, applies predefined or dynamic rules. Example, if delay is greater than 2 hours, then priority should be high. Reroute immediately. If a rule is triggered, it sends a command to the orchestration engine. This layer transforms raw data into actionable intelligence. Then we have orchestration layer. We have orchestration engine, example temporal or Kamuda. This receives workflow triggers from the business rule engine, manages complex stateful workflows such as rerouting shipments, notifying stakeholders, logging an incident. Workflow steps are versioned, traceable, and recoverable. Routing and rerouting service. Queries, real-time maps, traffic APIs, and carrier availability. Returns alternate routes. Updates the shipment's route in the operational database. Instead of hard coding reroute logic, we let workflows orchestrate what to do when something goes wrong. Then we have the notification and UI layer. Here we have the notification service that subscribes to the Kafka topics like reroute.initiated and delay.alert. This sends alerts via email, SMS, and push notifications. Also updates the dashboard via APIs or WebSocket. Then we have customer UI or mobile app or dashboard. This receives updates like your package is delayed due to traffic, ETA 4:45 p.m. or package rerouted via alternative carrier. The customer stays informed every step of the way. This is the visible outcome of the behind the scenes orchestration. Then we have the data layer here. Here we have the operational database. This stores latest shipment status, location, reroute data. This reads and writes operations by tracking and routing services. Then we have event store, Kafka log, long-term archive of all Kafka messages and useful for replays, audits, or time travel debugging. Then we have the historical data store or feature store. This feeds ML training and real-time feature generation used by the prediction engine to learn from past delays and outcomes. Now let's talk about the data flow and triggers. We have these blue arrows which are event flow. We can see the blue arrows from shippers and GPS to Kafka, and from Kafka to tracking, prediction, and rule engine. And we have internal interactions represented by the black arrows. We can see internal interactions from prediction engine to Kafka and from rule engine to orchestration to rerouting and from services to DB. And we can see notifications represented by orange arrows. Here we can see orchestration route, notification and customer UI. Every arrow in this architecture represents a real-time decision, a system call, or a user-facing insight. In this system, every shipment becomes a live data stream. Kafka handles the scale, microservices analyze the context, the orchestration engine acts, and customers see results in real time. This is modern logistics built for real world complexity. Like and subscribe for more videos like this.